Look up at the night sky, gaze into the infinite expanse above, and let your imagination wander. For all of human history, across cultures and generations, we've looked up and wondered, are we alone in this vast cosmos? This question has echoed through time, whispered around campfires and etched into the very fabric of our being. Could there be other worlds out there, perhaps orbiting distant suns, worlds that mirror our own in some way? Could they harbor life, or the potential for it? This fundamental question connects us to our ancestors, those intrepid explorers who charted unknown territories on Earth, and it drives us, with the same spirit, to explore the universe beyond. The universe is vast, unimaginably so, filled with countless galaxies, each a swirling island of stars, blazing suns like our own, and planets, a diverse array of celestial bodies, some rocky, some gaseous, some potentially habitable. The idea of finding or even making another Earth, a second home for humanity, is a powerful dream, a vision that captures our imagination and fuels our ambition. It's not just about survival in the face of potential threats to our planet, but also for the future of consciousness itself, for the continuation of our species and the preservation of our unique perspective on the universe. Life, as far as we know, is rare and precious. On this small blue dot, our Earth, billions of years of evolution have led to us, beings who possess the extraordinary ability to contemplate the cosmos, to question our place in it, and to dream of what might be. Imagine carrying that spark of life, that flame of consciousness, to another world, planting the seeds of a new beginning in a new cosmic garden. Imagine making humanity a multi-planet species, ensuring our survival and expanding our horizons beyond the confines of Earth. This isn't just science fiction confined to the pages of books or the screens of movies. It's a profound expression of our innate human instinct to explore, to push boundaries, and to venture into the unknown, just as our ancestors did. It's about securing a future for generations to come, a future where humanity thrives among the stars, carrying our legacy forward. Today, our oceans are no longer just the bodies of water that separate continents. They are the vast interstellar distances between planets. Our ships are no longer made of wood and sail, but are powerful rockets, capable of traversing the void, and our new worlds are the planets and moons of our solar system, each a unique and challenging frontier waiting to be explored and potentially transformed. The desire to make another planet like Earth, to terraform a barren world into a vibrant ecosystem, is the ultimate act of exploration, pushing the boundaries of what's possible through ingenuity, innovation, and a relentless pursuit of knowledge. By thinking deeply about the challenges and possibilities of transforming another world, of engineering a new environment, we inevitably learn more about our own planet, its delicate atmosphere, the intricate balance of its ecosystems, its vast oceans, and its complex climate systems. This cosmic perspective, this ability to see our planet from afar, helps us appreciate just how precious and fragile our home truly is. The dream of a second Earth is, therefore, also a powerful dream of understanding and protecting our first Earth, of becoming better stewards of our planet. It's a journey that begins with a single powerful thought, a spark of curiosity that ignites our imagination. What if we could give life another home among the stars, ensuring its survival and allowing it to flourish in new and unexpected ways? The story of life, our story, doesn't have to end here on Earth. It can continue, evolve, and expand across the cosmos. Humankind has always looked to the stars, wondering if we could ever call another planet home. What does it truly mean to transform an alien world? To make it not just survivable, but truly like our own Earth? The answer, the grand vision that captures this ambition: terraforming. Terraforming at its core means reshaping a planet to mirror Earth, to recreate the conditions that allow life to flourish as it does here. This involves fundamentally changing its atmosphere, carefully adjusting the temperature, and introducing a thriving ecology to make it a truly habitable world for humans and countless other species. It's not simply about constructing domes or sealed bubbles for protection. It's about undertaking the monumental task of transforming an entire planet, so that one day you could step outside and breathe the air without the need for a cumbersome spacesuit. Imagine yourself as a planetary architect, a cosmic engineer. Your mission: turning a hostile, desolate world into a vibrant, living ecosystem. Is the planet perpetually too cold, locked in an eternal winter? Then you would need to find ways to warm it up, perhaps by introducing greenhouse gases. Conversely, is it a scorching inferno perpetually baked by intense heat? Then you would need to cool it down, perhaps by reflecting sunlight back into space. Is the air too thin to breathe or filled with toxic gases? Then you would need to replace it with a breathable mixture, rich in life-giving oxygen. Does the planet lack water, the very essence of life? Then you would need to find a way to import it, to bring this precious resource to the parched world. One potential method might involve carefully guiding icy comets from the outer reaches of the solar system, directing them to crash onto the planet's surface, delivering their frozen cargo. Terraforming represents planetary engineering on an almost unimaginable scale, a project of truly epic proportions. It's a process that would likely unfold over centuries or even millennia, a testament to long-term vision and commitment. Each and every step of this grand endeavor would need to be meticulously planned and executed. The initial focus would be on the big picture, changing the fundamental conditions of the planet, adjusting the temperature to a more comfortable level and creating a breathable atmosphere. Then the slow and careful introduction of life, beginning with the simplest forms, hardy microbes and bacteria, followed by the introduction of plants, carefully selected to thrive in the new environment, and finally, the introduction of animals, completing the circle of life. Today, the concept of terraforming remains largely within the realm of our imaginations, explored through scientific models and thought experiments. But by studying the possibilities of terraforming, we gain invaluable insights into what makes Earth uniquely habitable, and how we can better care for our own precious planet. It's a powerful mental exercise, pushing the boundaries of our understanding and preparing us for a future filled with possibilities that we can only begin to dream of today. When searching for a terraforming candidate, one planet stands out: Venus. Venus is Earth's twin in size and gravity, but it's a twin gone wrong. Instead of blue oceans, Venus is shrouded in clouds of sulfuric acid, hiding a surface of crushing pressure and searing heat. Its atmosphere is 92 times thicker than Earth's, made almost entirely of carbon dioxide. The result, a runaway greenhouse effect, making Venus the hottest planet in the solar system. Billions of years ago, Venus may have been more Earth-like, with water and a milder climate. Something changed, turning it into a hellish world. Understanding what went wrong on Venus is crucial, not just for terraforming, but for understanding Earth's future. Venus is a cosmic cautionary tale, showing how a beautiful world can be lost. Its transformation is a mystery we must solve. To truly grasp the monumental challenge that terraforming Venus presents, we need to understand the sheer scale of the undertaking. It's not just about tweaking a few things, it's about fundamentally altering an entire planet. We must compare it directly to our own home, Earth. Earth's atmosphere is a breathable mix, composed mostly of nitrogen and oxygen, a composition that's not only suitable, but absolutely perfect for life as we know it. It's a delicate balance that has allowed ecosystems to flourish, and Earth enjoys a mild average temperature, a comfortable climate that supports a vast array of habitats. In stark contrast, Venus's atmosphere is a suffocating blanket, composed almost entirely of carbon dioxide, a dense and toxic environment. This thick atmosphere relentlessly traps heat, creating surface temperatures that are hot enough to melt lead. It's a scorching, hellish landscape. There's almost no water on Venus. The very essence of life as we understand it is absent. Any ancient oceans that might have existed boiled away long ago, leaving behind a parched and desolate world. Earth spins at a reasonable pace, completing a rotation every 24 hours, giving us the familiar and essential cycle of day and night, a rhythm that governs life. But Venus rotates incredibly slowly, so slowly, in fact, that a single day on Venus lasts longer than its entire year. This extraordinarily slow spin would inevitably create extreme temperature differences across the planet's surface. These temperature extremes would make sustaining life, even with advanced technology, incredibly difficult. Earth benefits from a robust magnetic field that acts as a shield, protecting us from harmful solar radiation. Venus, however, has none of this crucial protection. It remains completely exposed to the constant bombardment of the solar wind. Over billions of years, the relentless solar wind has likely stripped away any significant amount of water that Venus might once have possessed. Therefore, to make Venus a habitable home, we'd need to find a way to drastically cool the planet, completely replace its toxic atmosphere with a breathable one, introduce vast quantities of water, and somehow devise a method to protect it from the ravages of space. The differences between Earth and Venus are truly staggering, and each of these differences represents a major, almost insurmountable challenge. Yet, it is precisely these challenges that make Venus the ultimate proving ground, the most demanding test for the future of planetary engineering. If we could somehow succeed in transforming Venus, then we could potentially apply those same techniques to terraform almost any other world in the cosmos. But first and foremost, we must find a viable way to tame the planet's oppressive heat and its dense, toxic atmosphere. Only then can we even begin to dream of transforming Venus into a second Earth, a verdant and habitable world. The journey to achieve this would be nothing short of epic, a testament to human ingenuity and perseverance. The first step to taming Venus is cooling it down. The thick carbon dioxide atmosphere traps sunlight, so we must block the sun's energy. One idea: build a gigantic sunshade in space, casting a shadow over Venus. With less sunlight, the greenhouse effect would weaken, and the planet would cool over centuries. As Venus cools, carbon dioxide would condense and fall as liquid or dry ice, thinning the atmosphere. The crushing air would literally fall out of the sky. Building and maintaining such a sunshade would be a monumental engineering feat. But if we could do it, it would unlock the next steps in transforming Venus. Cooling the planet is the key to everything that follows. Once Venus is cool, and its carbon dioxide has settled, the real work begins, building a new atmosphere and adding water. We can't leave dry ice lying around. It must be locked away, perhaps by reacting it with surface minerals to form stable rocks. This would require massive mining and processing operations. Next, we'd need to import nitrogen, maybe from Titan, to create a breathable atmosphere. Water would have to be delivered from icy comets or asteroids, redirected to crash onto Venus and form oceans. Each impact would bring millions of tons of water, eventually creating rivers, lakes, and seas. It's a cosmic rainstorm that could last centuries. Only then could life begin to take root. Even with a new atmosphere and oceans, two colossal problems remain: Venus's slow rotation and lack of a magnetic field. A day on Venus lasts 243 Earth days, too long for Earth-like life. Spinning up the planet would require unimaginable energy, perhaps by redirecting massive asteroids to nudge its rotation. The risks are enormous. A miscalculation could be catastrophic. Venus also lacks a magnetic field, leaving it exposed to solar radiation. We'd need to create an artificial shield, maybe a giant superconducting ring in orbit. Both challenges are far beyond our current technology. They are the final bosses of planetary engineering. Without solving them, Venus can never truly become a second Earth. Even if we could terraform Venus, should we? Venus is unique with its own history and beauty. Do we have the right to erase that? If we found even simple life in Venus's clouds, destroying it would be a cosmic crime. The risks are immense. What if we make things worse or cause unintended consequences for the solar system? The resources required would be astronomical. Could they be better used to solve problems on Earth? These questions force us to consider our values and responsibilities as a species. Do we see the universe as a resource, or as a place to be preserved? The debate over terraforming is really a debate about our future. It challenges us to think deeply about our place in the cosmos. The most important part of this conversation is that we have it before we act. The dream of terraforming Venus may be distant, but its value lies in what it teaches us now. By studying Venus, we learn how to care for Earth. Venus is a cautionary tale of climate gone wrong, a warning for our own planet. It reminds us to protect our atmosphere and invest in science and innovation. These cosmic dreams inspire us to be bold and curious, pushing us to solve big problems. The next generation, inspired by these ideas, may create technologies that help both Earth and space. Venus teaches us about fragility, responsibility, and the power of imagination. The journey to the stars begins by looking up, and by looking after our only home,